All right, in section 4.4, we will be examining some properties of logarithms, and those are going to allow us to simplify some kind of complicated expressions. Okay, this is really something important to use when we are going to be solving some logarithmic equations, and we use this quite a bit in calculus as well. All right, let's look at property number 1. It's called the product property of logarithms. This says if you have a product as your argument in a logarithm, okay, you have the log of the product x times y with base b, that can be broken apart into the sum of two logarithms. The log of the first factor x with base b added to the log of the second factor y with base b. Okay? If you want to verify this, let's let our base be a 10 just so we can use our calculator. Y'all punch this in. What is the log of 6? That's going to be the same thing, I bet, as the log of 2 added to the log of 3. Because 6 is 2 times 3, right? And so that's a direct application of our product rule for logarithms. Let me show you that real quick. This doesn't prove this, but I mean this is a rule. But check this out. Log of 6. Remember that number, okay? Now what I'm going to do is I'm going to do the log of 2, and then I'm going to add that to the log of 3. And I bet we're going to get 0.778151, exactly the same thing. All right? That's magic. A little mathematical magic there, friends. All right. So what else we can do with it is simplify some stuff. I don't know why I'm having such trouble scrolling on this. How about we do it like that? Okay? It says write the logarithm as a sum and simplify if possible. Assume that x and y represent positive real numbers, so everything's all defined. We don't have any domain issues. First of all, we know that we've got a factor of 49 and a factor of k. So to apply our product property for logarithms, this is the same thing as the log of 49 with base 7 added to the log of the second factor, k, with the same base 7. See how that works? All right. Now, it said to simplify if possible, and hey, y'all, I know what exponent I use on 7 to give me 49. The log of 49 with base 7, y'all, that's just 2. Because 7 squared gives me 49. Remember what those logarithms mean? Now, I don't know what exponent to use on this 7 to give me k, because I don't know what k is, so I really can't simplify that term. I'm just going to bring it down. Okay, so there's my answer written as a sum with things simplified as possible. Okay, let's try this one. I have a factor of 24, a factor of v, and a factor of w. This is going to break down into 3 terms. We're going to have the log of 24. Now, this is understood to be with base 10. I might want to scratch that in there. I don't know. It's not necessary. Added to the log of v, understood to be with base 10. Added to the log of w, with understood to be base 10. You know, I really don't think I want that 10 in there. Whoa, I can't just move it. I really don't think I want that 10 in there because 10 to what power gives me 24? Nothing that's pretty. So I guess I could punch in the log of 24 on my calculator and get a decimal for that. But I don't know that we'd really have any kind of advantage to do that. I'm just going to clean this up and say there it is. That's about as good as it gets. Because that first term, yeah, I could find a number for that, but it's going to be ugly. All right, it's going to be a decimal, so I'd rather not. Okay, what else do we got next? Quotient property. Okay, this works kind of like the quotient rule for radicals. Why in the wide world of sports can I not just scroll like a normal person? All right, quotient. If we've got the log of a quotient, x divided by y, okay, that's going to be the log of the top minus the log of the bottom. Okay, now the reason for that is another way to write that log of x over y is you could say x to the first, right, times y to the negative first, okay, with base b. Oh, that didn't really show you anything yet until we know the power property for logarithms. So anyway, there's the quotient property. That's a subtract in between there. And so on number 14, for example, okay, the log of the argument m over n with base 9 can be rewritten as the log of the numerator m with base 9 minus the log of the denominator n with the same base 9. That's as good as that gets. Okay, we wrote the logarithm as a difference of logarithms, right, with the minus sign, and no simplifying on that one. Okay? Oh my goodness gracious. When I'm trying to scroll, it's not liking that. Maybe just let me do that. There we go. All right, on number 18, this is going to be simplified as the log of 1,000. Now, understood to be with base 10. Ooh, that's going to clean up. Minus the log of, I'm going to run out of room here. Gosh darn, c squared plus 1 with base 10 also. All right? Now, for this term, I know what exponent I use on 10. 10 to the what gives me 1,000. What should go here? I know that that is 3. Here I can't really do anything on the next term, so I'm just going to bring down minus the log of c squared plus 1. And you can write with the base of 10 if you want. It is really not necessary. We know it's understood to be with the base of 10. Okay? So that's all nice and simplified. Let's see, what's next? The power property. Let's go ahead and let's do that in this video as well. The power property, this one is wild to me, okay? It says if you've got the log of x to the p power with base b, what you can do with that power is slide it down front. It's going to be p times the log of x with base b. Okay? So, what this means, let's just do a little simpler one. What if we have the log of, I don't know, let me do 18 with base, I don't know, 2. It doesn't have to be anything pretty. Okay? Well, we know that 18 is the, no, it's not. Hold on. Let's not do 18. Let's do 81. That'll work out better. Okay? This is the same thing as the log of 9 squared is 81 with base 2. This is going to be the same thing as 2 times the log of 9 with still base 2. Wild, huh? The 2 comes out front there. So on number 22, what we want to do is we want to take this 4th root of x cubed, and we want to go ahead and rewrite this. Logarithm with base 8, and the argument is x to the power over root, right? That's how we go from rational exponents to radical form and vice versa. So really, all you can do here is bring the 3/4 power down front. This is equivalent to 3/4 multiplied by the log of x with base 8. That's really as good as you can get there. On number 24, this is, if you want to write this as the log with base e, you can. But really, all we need to do is slide that power down front. This is the same thing as r times t multiplied by the natural log of 0.5. Okay? Now, I don't know if they want us to get on our calculator and crunch the natural log of 0.5. Well, I don't have that. So I guess we're done right here. All right.